Hi, David. How are you doing?
I'm doing well, Lily. How are you?
I'm good. I'm good. Thank you. So you're going to try and demystify data science. And I know that you're ambitious, but considering you try and stick our videos to 5 minutes or less, I'm intrigued to see how you do this.
Yeah, I almost certainly failed, but I'll give it a shot. But basically, data science is working with data, and what it does is it draws predictions, categorizations, information out of data.
So the statistics, right? So that's
this is the thing. Many statisticians feel that data science should have been statistics, but it's not. And one of the reasons it's not is statistics was born in an era of data scarcity. Statisticians are experts at making the most of a small amount of data. I love, polls. A small number of people can be asked questions and you get information which is corresponding to the whole, state of the nation, of what the nation is thinking. This is the power of statistics. This is what statisticians are experts at. But data science is born out of an era of data mining and big data and, data abundance is how I like to think of it. And the point there was, if statisticians had wanted data science to be part of statistics, well, then when data mining came along, they should have said, that's ours. But they didn't. They said, oh, we don't want anything to do with that. It doesn't have the modeling that we want. It doesn't have, and so they lost the potential to sort of own data science, machine learning algorithms, and so on, because this was sort of not deemed statistical enough.
As a statistician, I want more data. It's not by choice that I have a scarcity of data.
But the methods behind that are considered, if you don't have a design to the study, then you're scared about where's the data's come from and what conclusions can you draw. Rightly so, as we'll see with data science. But the point is that if you're in an era of data abundance, well, there are some questions that you can answer extremely well, even without that caution that would come in from a more statistical approach of designing a study and the rest of it. And thinking of sort of your inference and your sort of population versus your sample.
But how does having this kind of abundance of data, how does that, surely we just do the same methods between them, right? Like it's data's data, as you say.
It's just data. Data is just data. And in essence, you're right that a lot of data science, machine learning methods are born out of, or maybe include, the sort of statistical modeling and statistical methods at the heart of it. But what they do, by and large, is they then sort of say, well, okay, I can do that on part of my data, and then I can use the rest of my data to try and understand, well, what can I do with the unexplained variability? In some sense, that's what they're able to do. They're able to then go deeper. And some of the methods to go deeper were great. They come back to my area. They use algebraic geometry. They use topology. They use other areas of mathematics because you have an abundance of data now. And so you can talk about the shape of your data. You can think about this in ways which are more abstract, which, the traditional statistics methods are much more on the measuring, sort of coming from measure theory, your sort of more a small subset of mathematics is sort of part of the measurement tools. And really, at the heart of it, those are really important because you're wanting to they're important for understanding the data, but it's not all there is in the data.
But just because I now have this abundance and I can explain more variability, it feels to me like AI and machine learning, these are big terms and they sound complicated. There's a lot of complexity there, but you're just saying it's.
Some people might feel that algebraic geometry is complicated. And so,
yeah, I do. Yeah.
So they do use complicated mathematics and complicated methods. But in essence, what they're doing, remains relatively simple. They are still understanding the variability of the data and they're using it to predict. They're using it to categorize. And that's where, it's not so different in the end result. It's different in the methods.
Okay. So what can they do? What can't they do?
I mean, what can't they do is really go beyond the data you feed in. You know, at the heart of it, there's still methods for working with and drawing information out of your data. So they can't go beyond the data, really. What can they do? I mean, it's just so powerful. I mean, the example I still love is the very early one, before we talk about people, even you had language and machine learning and AI. The post office, you know, they can read an address automatically, which means you can automate the sorting in the post offices, which is a huge deal. You know, if you can reduce the problem to something which is specific enough, you can automate it. ChatGPT has done that at a slightly bigger level, you know, and there's more you can do. But you know, in its essence, if you can reduce the problem to something well defined, well, probably you've got enough data now to be able to give you an answer. If you have lots and lots of data on what you've been shopping in the past and what other people who have shopped similar things in the past have been doing, then yeah, you might well be able to predict what you're going to want to buy next, which is one of the, yeah.
No, very interesting. Thank you very much.
Have I made it under 5 minutes?
I don't know.
Oh, I hope so. Anyway, this was hopefully, I don't know if I succeeded at demystifying it for anyone, but hopefully this is a perspective on data science, which is not scary and
Thank you very much, David.
just